The opening of the portable ultrasonic flow meter by Tactical Flow. This system, this box is 24 by 16 by 5 inches high, shipping weight 24 pounds, has the electronics, which is battery powered or AC powered. You could run it on this AC powered supply. These are the straps that hold the racks on. This rack is for the smaller diameter pipes. This rack is for the larger diameter pipes when the V is greater than the length of this rack. This rack is for the Z pattern when one is put on one side and one is on the other. These transceivers are removable and can be put in there. So there's no real need for this unless you're doing the Z. This is a roll of paper. These are the two temperature transducers. These, there are two sizes of transceivers in here. This is the small one. You could probably see, but there's about a half-inch diameter piezo transceiver in there. In this diameter is about 3/4. You can't really see it. The energy from this is much greater than the energy from this, because there's no need to put lots of energy in a little pipe. The markings show the spacing, and the spacing is attained by learning from the machine what the spacing needs to be, setting this at 0, setting the upstream one at 0 with a little mark here, and setting this one to whatever dimension is. These units are 30 seconds of an inch. 8, 16, 24, 32. So you can take your dimensions and turn it to 30 seconds of an inch. The straps are nylon, and they go around here, and there's magnets here that hold it onto magnetic pipes. And these either straps are for holding the temperature transducers. One goes on the hot, one goes on the cold. When you're using this as a BTU meter. Normally, most folks use this just as a ultrasonic flow meter, and the BTU part is Q is BTU equals m dot, mass flow is derived from this, C sub P of the fluid is a property of the fluid, delta T. These two transducers, one goes on the hot side, one goes on the cold side, and from that, Q equals m dot C sub P delta T, we tell you the BTU in whatever units you want, joules or BTU. The way the machine is set up, the first thing is we start with a cheat sheet, and this meter is going to be set up for a 2-inch plastic PVC pipe. Hold the on for 4 seconds. It will sign up, and we're going to enter menu 23. Clamp on TS2. Next is V mounting. The spacing, we'll see if it says it's 1.473, but going further on is menu 11. Then we go 2.375 is the pipe OD, down the wall thickness 0.145, down IDs 2.085. The materials PVC, no liner. This is for water. It's a clamp on TS2 as shown here, and it's in the V configuration. And this is the number that we fill out here, 1.473. 0.473 divided by 32 is 15. So if it was 1.5 divided by 32, it would be 16. So it's 1.473. So we're going to use this, and we're going to set it to 1 and 15 30 seconds. On the inch side, set the red one upstream to 0 and set this one to 1 and 15. This is 8, 16 minus 1 is 15, and we'll get it there. And just to check, we could use a micrometer. Not many people have these silly things. Do is as you're using the instrument, you can use menu 90 to look at the signal strength and move one of these transducers just a little bit back and forth and watch for the greater signal strength. So we're not done setting it up. We now know the spacing. The next thing we have to do is set up the output. So that's menu 55, menu 55. We want 4 to 20. Some folks may want, there's other values, 0 to 20, but 4 to 20 is the most common value. Enter. And then down, we want to have 4 to 20 milliamp is 0 gallons per minute. This is going to be a 50 gallon per minute flow meter. We can test the output. We can set the date. Serial numbers down. Now we want menu 67. Menu 67. 0 to 1000. If you're using the frequency output that comes from the outputs on this connector, you can set this up to 0 to 1 kilohertz. And the flow rate is 0, and the full scale. Frequency out is 50. So LCD backlight option, I turn it to 99 so it stays on. LCD contrast. And now we want to do menu 60 to set the date, 2/08/02/13. So the date's correct, but you hit enter and just follow that format. Year, month, day, date. And the last and most important thing to do is, as shown here, enter menu 26, menu 26, enter twice, it'll beep, listen. So it beeped back at us. And when I hit it now, there won't be a secondary beep. So now it's ready for connection. The connections are red and blue, red and blue. So these connectors go to the transceivers, and I'm just gonna hook this up. Down is blue, and it really doesn't matter the colors. It's just kind of a little helpful hint. Red is up, and secure it, and down is blue. This screw, the large one, is for the purpose of securing the transceiver in its place. So once it's where it needs to be, so you can move it back and forth. So we'll put it back to 15. Then this screw is for the purpose of advancing and retracting the transceiver relative to the rail. So you start with it down all the way counterclockwise, and then we're going to go place this on the pipe. We're going to secure it with the straps. We want to have the upstream 5 diameters of the pipe away from any bends or elbows, and then the downstream 3 diameters down. So the transceivers are going to shoot the energy down, bounce back up, come into this one. It's going to shoot this down, and it's going to bounce to this, and this guy knows when it's sent it out, and this guy receives it, says, oh, it took 10 milliseconds, and this one does the same, 10 milliseconds. There must be no flow. 5 milliseconds, 10 milliseconds. There must be a lot of flow going that way, because this took 10 milliseconds, and this took 5 milliseconds. So it does internally the extraction of the index of refraction of the material, for the sound, and it knows the sound speed of the material. So it's a very, and this thing runs at 1 megahertz. This is a real sophisticated system. So next I will show you how it connects to the pipe and how to read the values. In the box is also this more permanent mounting for holding these on should you want them, but generally people use these as QC tools. So that is it for the instrument. Here's the system connected to PVC pipe with the straps on the top and bottom. Once they're secured, you secure them tightly with the blue strap is the adhesive part, and tighten it with these counterclockwise fully, and put both straps on, and then turn these until the straps are tight, and you have the proper distance, which is there. And here we have a low flow. This is a 2-speed pump. It'll change. It'll only go to like 20 gallons per minute. We'll turn it back off and allow. So there is the connection. Menu 9.0, quality is 89, 94%, so that's a good signal. Menu 00 brings you to all the information up. This is the total, and you can look at the quality is 95%. And if we had the delta T on here, this would measure the temperature difference between the two. And so you can look at all the information on here, menu 00, and go down the other way and look at other elements. Flow today has been 196 gallons. So there's the ID and OD 2.375, 145, 2885, DVC, clamp on, so menu 00. So now it's reading, this is the rate in total. Another important menu is menu 40. Menu 40 is the time constant. Enter 1 for really fast tuning, and menu 00, you can watch the flow rate. Menu 40, enter 4 seconds is a good average number to leave on there. Menu 26, enter twice, and that solidifies the settings. Anytime you make any changes that you want to save, menu 26, enter twice, you'll hear a confirmation beep. So if no changes were made, menu 00, back to the normal rate